Testing. All right.
All right.
All right. Here we go. Hi, everybody. Thank you very much for attending today's LLM Avalanche meetup. There's a bunch of folks obviously here. For everybody that's outside, we are simulcasting it to the Grand Lobby as well. So, saying this, without further ado, why don't you do the introductions?
So, everybody, welcome to LLM Avalanche. We're very happy to have you here. The first LLM event of this capacity in the world, right? The shortest, biggest conference.
Absolutely.
The shortest, biggest conference ever. And we're very happy to have with us Matei Zacharia, who is the Chief Technologist at Databricks, Apache Spark creator. I know him for a decade in the community, the open source guy, and he will open this up.
Oh, we did forget something. I'm Denny Lee from Databricks.
And I'm Alexei Krabarov by Air AI Scale by the Bay.
All right, perfect. All right, now to Matei.
All right. All right. Thanks so much, Denny and Alexei, and everyone who's been organizing this meetup, including Demetrios and the whole team. We're super excited to see, this group here and all the amazing speakers we have today on everything from open source LLMs to, the latest and greatest research to all of the ecosystem of technology you can use around this stuff. So as Denny said, I'm a co-founder of Databricks, or one of the hosts of this event. Very excited to see everyone here. So it's a very large meetup. I think we have about 1,000 attendees total, and wide representation on our panels from quite a few companies in this space. We'd like to thank all the sponsors involved. This came together, very quickly with some amazing companies and organizations contributing to it. So thanks so much. And I just want to give you, a quick look at the speakers. There are actually so many exciting things that, I probably don't even have time to read all of them. But we have, I think, many of the, kind of most well-known startups in this space. We have folks giving talks on everything from just training language models to applying them to securing them and so on. And we also have some amazing speakers from research, such as Akanksha, who led the Palm 2 effort at Google, and many others as well. So really looking forward to a great evening here. I hope everyone enjoys it and has a chance to meet some exciting new folks. So next, Alexei, I think, wants to say a few words.
Thank you, Matei.
Want me to hold your alpaca?
All right, and now I want to introduce Paige Martin. She is a steering committee member for Open Source Science. That's the initiative which we've co-founded with IBM at NumFocus. So Open Source Science connects open source developers and scientists around the world to accelerate science, solving hardest problems of humanity, such as new materials, healthcare, climate change, and sustainability. So Paige is also a steering committee member for Pangeos. She's an oceanographer from Columbia University, now with NASA Transition to Open Source Program. In August, she's going to Ghana to teach data science, and all the donation passes from your passes, plus sponsorships, are going to Paige, so and NumFocus will give it to students and children in Africa studying data science. So she has a few words.
Computational science. We have a few initiatives that we've started already, including these working groups that are across various scientific disciplines. We also have a few other topics, like mapping across science, where the idea is we'll kind of map together what tools are being used by which scientific disciplines and where there might be gaps that we can help fill. One of the great benefits of open source software is enabling a more inclusive global scientific research community. So I've had the pleasure the last 5 years to teach data science literacy in West Africa at the Coastal Ocean Environment Summer School in Nigeria and Ghana, which is a bit of a mouthful. We call it COESING for short. And through this program, I've met individuals and organizations that are doing absolutely amazing work in West Africa to provide education and skills in computational research, in software development, and in data science literacy. Your donations will really help to continue and expand upon all of these great efforts and help the West Africans play active parts in the global scientific research community. So thank you very much.
And then it just tells me our total donation fund exceeds $21,000. So thank you, everybody. And now we have really full program, right? We are really tight. It's the shortest, biggest conference in the world. So we have panels, we have lightning talks, right? The panels are happening here. This room is called Goldman, but now we call it Llama. So it has Llama Science. The lightning talks are in Youth Gallery, which is second floor, which we renamed Dolly. So you will see Dolly Science next to Youth Gallery. And we have the open mic, which is happening downstairs here in the blue cube. We call it Orca. And try to guess why. So yeah, the panels basically start at 6 o'clock. We have a trust panel. Then we have enterprise and deployment panel, performance panel, and building risks panel. So basically that's the plan for the panels. And the logistics are, I think I just mentioned this, right? So this is trust and enterprise deployment break, then 2 more panels. And this is the stocks, and let Danny to talk about the stocks.
All right, so just okay, so you head upstairs if you want to attend any of those sessions. They're going to be running approximately 8-minute cadences, so that way they're literally lightning talks. So we're going to keep them relatively quick. Before the break sessions will be moderated by Adi Pollock, and the after break sessions are going to be moderated by Xing Chen. Okay, so we've got, again, very packed schedule. Now, as Alexei called out, we also have a science fair. Okay, the science fair is located in the community showcase area of the Blue Cube or Orca. All right, we have 3 sessions located for 6 o'clock and 7 o'clock. And we also have 4 sessions located from between 7 o'clock and 8 o'clock. And then finally, we have an open mic session, also running at 7 to 10 minute cadences, all throughout from 6:30 to 8:30. So again, we have a packed schedule. Now, a lot of these things are going to be are going to go ahead and be run, basically simulcast also in the grand lobby. So if you can't get in, it's okay. We're going to simulcast the stuff to the grand lobby as well. Now, without further ado, I want to introduce Karen for the hackathon.
Cool. Hi, everyone. So I have the honor of announcing the winners from our hackathon today. About 80 folks were at the Intercon Hotel all day hacking. They hacked for about 6 hours today, and we are going to announce the winners right here on stage just a few hours after they finished hacking. So maybe we can do a quick round of applause for all the participants and all the awesome projects. Over 80 participants submitted over 17 projects. Really awesome. The scores are really close, so just really awesome work from all of them. Thank you to all the judges and mentors. We had a lot of folks reviewing the projects and had a great time. So thank you to all of you who helped us score the projects. All right, so we're going to do third, second, and first place. And so third place, the prize is $2,500. And we're going to do a nice celebration and shout out for each of the winners at one of the keynote presentations at Summit. So without further ado, third place, the project winners are Commit with a Bang. Woo! And I know all the participants and the winners are spread throughout the venue, so I'm going to, after this presentation, I'll go out in the front. So please, if you won one of the awards, come find me, and if you don't, I'll make sure I find you, got your emails, so we can discuss all the award details and make sure we get you your award. All right, second place. So second place is a total of $5,000. And second place is Pharma Assist. Woo! All right, and first prize, the grand prize winners. This award is $10,000, which is pretty awesome. So first prize is Schema Spy. Awesome, so that's it for me. I'll find everyone after this presentation. Thank you.
We're going to start the first set of panel discussions here in about 5 minutes. If you want to go to the lightning talks, open mic, or to the science fair, this is the time for you guys to do it, and we still have snacks outside. Thank you very much.
And we have beer and snacks and everything. Enjoy.
Hello, everyone. It's great to be here today. Hands up if you can hear me well. All the way to the back? Fantastic. Can you keep your hands up for a little second more? Let's do a quick selfie to show all the great love for LLMs today. All righty. Fantastic. Thank you for playing all in. So Maria here is going to talk about why MLOps and LLM ops is necessary, why is it booming. And one thing to know about Maria, she actually creating a blog where she drove the name using ChatGPT. So Maria can probably share a little bit more about that story and how she's working with prompting to create better content. So I hope you're excited and giving the space to Maria.
Hi, everyone. You hear me well, right? Okay, cool. Well, very exciting to be here in San Francisco. I'm heavily jet-lagged. I haven't slept for quite some hours from Amsterdam. So it's, yeah, I hope my message will come over clear. So I will be talking about why MLOps and LLMOps is booming and how you can catch up. And it will be about corporate setting, how to do that in corporate setting. So I'm a lead machine learning engineer at Ahold Delhaize. It's one of the largest retailers in the world with a lot of brands, 19 brands in Europe and in the United States. And I'm leading MLOps transformation there across all the brands. I have approximately 10 years experience in data analytics domain. I've been doing all kind of jobs starting from data analytics to data science and machine learning engineering, and 7 years my focus was on MLOps specifically. So I've done data analytics, data science, and machine learning engineering in large corporate organizations, so I know a lot about politics, not just about data science and machine learning engineering. We also will be talking at Data and AI Summit on Wednesday. We will be talking about API deployment with model endpoints, with serverless model endpoints from Databricks, and how we applied that. We have not done that yet with LLMs, but we are planning to do so in coming couple of months. So as was mentioned in the introduction, we do have a blog. It's called Marvelous MLOps. So it comes because we are both, me and my colleague Bashak are both fans of Marvel and MLOps. So we asked ChatGPT to come up with a name, and it told us Marvelous MLOps. So that's how it got started. We are really Marvel fans, so I'm wearing Infinity Stone ring, and also Bashak. So are there many Marvel fans in the room? Yeah? Okay, well. And MLOps, obviously, everyone, right? So that's cool. So if you're interested to follow us and read about our journey, please scan the code. So what the talk is going to be about, the story of MLOps and LLMOps, MLOps adoption challenges and what you can do now to overcome them, and LLMOps adoption, possible use cases, the challenges that are out there, and how you can overcome some of them in the corporate setting. So we're not talking about startups or anything. It's really corporate setting, which is very different. So what does Google Trends tell us? It is actually funny. I was looking at LLM trends and data science trends, and it seems like LLM was more popular than data science for quite some time. Well, LLM also stands for Master in Laws, apparently. Well, it is funny. People are more interested in law nowadays than they were before. Well, of course, it's about LLMs that got really popular after December 2022. Everyone started talking about them, including my parents, which know nothing about AI. So it is quite funny. And you see that MLOps is also really progressing. A number of searches is really growing. And you see some dips in this graph. And if you look what dips those are, it is actually Christmas period. I don't understand why people don't care about MLOps around Christmas, maybe production freeze. I don't know, but it is funny. But LLMOps is not a term yet. So it still has to be maybe adopted more. So I guess LLM operations are seen more like part of MLOps yet, still. So what MLOps challenges do we have in large corporate organizations? It's hard to get buy-in from management to start with MLOps. If you just tell management, I want to build a MLOps platform, they will tell you, well, yeah, what's the business value? How can you do that? You need money, so it's really complicated, right? Scattered teams and not clear responsibilities across the teams, and a change management is required. If you look at the slide back, data science started getting popular around 2016, so that's when it got more popular than LLM. At that moment, big corporate organizations started doing data science. So that also happened to me. I started working in 2014 as a data analyst, and data science wasn't a thing back then, at least not in Europe. Maybe in the US it was already a thing. So data science jobs started appearing around 2015, 2016. But then data scientists started building some models, but there was no value coming out of it. Why? Because you have to integrate it with all the systems, and data scientists didn't have the knowledge to do so. And DevOps engineers or software engineers or other folks that did have the knowledge didn't know anything about machine learning. So that's why the boom of MLOps happened a couple of years later. So it is essential to do MLOps to actually start seeing the value from the data science. But to do this MLOps, indeed change management is required. So what we see a lot is that, well, that's what we have seen at Ahold Delhaize when I started working there a couple of years ago, that there was one big data science team within one of the brands. They were doing some use cases like demand forecast, cross-sell maybe on the website, personalized offers, and it was a separate team. There was also a team of DevOps engineers, there was a platform team. They were not really talking to each other. And if they wanted to get something done, the data scientists, they would literally have to send over an email with a zip file and all that crazy stuff, and they will send back error messages, and it will go over and over. So there is a lot of pain in this, pain from both sides. So what can you do if you're in such situation? So find people that feel pain. So if there is no pain, there is no need for cure, right? But if people feel pain, you can address that pain and make them your ally. That's what you can start doing. You can start with one project that already has buy-in from the management and deploy it in a reusable way so that you can apply whatever you used for every next project. Then you need to educate data scientists, DevOps engineers, platform teams on MLOps and why it is important to follow best MLOps practices. And speak loudly about every success you make. So for example, if you deployed one project in a reusable way, every next project will be done in a shorter amount of time. So example that I can give based on our experience within Ahold Delhaize, before it would take 9 months to deploy a cross-sell model on a website. Now it takes 1 month. The model brings huge values, like 100,000 euro per week. So 8 months difference times that amount per week, it would be like 3 million euro. And then you can tell everyone about it. Look, we just earned 3 million euro by doing this. And the more projects you do, the bigger the number becomes. So it's easier to sell within your organization. I think selling is really underestimated skill of machine learning engineers, data scientists, to actually promote the work that they do. And in the end, you need to build a MLOps platform that scales and supports multiple use cases. So MLOps becomes part of enablement. So then there are no scattered teams. There is a MLOps team that fully supports all the projects, and they are in constant communication with the platform team. So in our situation, for example, we convinced the DevOps and platform team that we know what we are doing. We got permissions to deploy ourselves, and we built a whole framework that allows data scientists to deploy themselves within 5 minutes if they wanted to. So it takes organizational change. It takes talking to people, or politics that people don't usually like, but it's inevitable. So simplified MLOps landscape can look in the following way. So you basically need some basic steps here. You need version control, you need CI/CD, you need orchestration, model registry, container registry, compute, serving, monitoring, feature stores. And there are a lot of tools here. So you probably all have seen this MED landscape. There are many, many tools. I don't think you need all those tools. You just need to combine whatever you have in a smart way. So I think that's how that works in a corporate setting for sure. So an LLM ops now. Does MLOps for LLMs require a new term? Well, LLMs are more complex than a traditional model. So because it requires more interaction with the business teams. You need more human involvement, the constant feedback loop. You need people to annotate things. It is also possible for more standard machine learning, like NLP tasks. But companies that were not doing that before on that scale, they need to start that conversation with the business. And you need to build something to do this feedback loop. So it may require an extra additional thing in your MLOps setup to make LLM ops possible. And I think when we're talking about MLOps, we are talking about more platform thing that scales. When we are talking about LLM ops, we are just talking usually about deploying just one model for now, because it's new. So we're not talking about doing it on scale yet, at least. But it will come. You see, everything will come in a couple of years, probably based on the search terms in Google. So what high-value use cases are out there at the moment that we see, at least from the corporate world? So customer support. I worked in a telecom company before. Customer support was always a big thing. We were already doing NLP for classification of chats and calls in 2016. And we already had this collaboration with the business there, so they actually see the value of all of it. And it's easy, I think, to start with these kind of use cases for those companies. For banks, the same, insurance. Retail, maybe some of the retail, it would also work. shopping assistant for retailers. It's an amazing opportunity for cross-selling. Cross-selling has huge value for retailers. So this gives an extra opportunity and actually makes kind of gamifications, I think, for the customers. So for clothes, furniture, home appliances, and for food retailers, recipes is a big thing. So, for example, people want to make pasta, bolognese for dinner, and they ask ChatGPT for recipe for this. And well, not ChatGPT, but this internal shopping assistant, recipe assistant, and it will come up with products that you can add to the cart directly. So it's an amazing opportunity for cross-sell. So some of the examples that I did using ChatGPT. So for IKEA furniture, so I asked ChatGPT, I have kids and cats and want to buy a sofa with removable cover. It must be medium soft because I have some back pain. Can you recommend different sofas from IKEA? Rank them and motivate in max 20 words. So it comes up with some IKEA products. I Googled some of them, it looks okay. So something like that would work for a furniture retailer, right? Another example is recommending clothes. So I'm a female going to a friend's wedding in Sicily and want to wear a petite size dress. Can you recommend some items to wear from Zalando.com? It's like in Europe, it's a big clothes retailer, and accessories and shoes to go with it. And it will actually come up with some suggestions. Well, because ChatGPT is outdated, those are not sold anymore. But I can imagine that for Zalando, they are actually doing that, by the way. They announced in April, I think, that they are actually going to do something like that. That's pretty amazing. There is huge value in it. But it's not always easy to reach. We need to get buy-in from the business again. It requires time and budget for fine-tuning because you cannot just use open AI for this or anything from Azure. You need human annotation and feedback, so more close interaction with business teams. And it takes time and it takes money. Available models don't work well for small languages. So because Ahold Delhaize works for 19 different brands, we have brands in Europe and in countries like Greece, Romania, Serbia, Netherlands, Belgium. So there are languages that are not English. So they are very challenging. And then you need to do something very custom to make it work. And it costs more money. So what you can do already, you need to get buy-in from the management. So you can start with low-hanging fruit examples, like internal knowledge base. That's something that we are going to do. Well, everyone knows Confluence. Confluence is horrible. You cannot find anything on Confluence. So scraping the whole Confluence, scraping the whole GitHub for README files, and scraping SharePoint all together, and taking Dolly and fine-tuning Dolly to answer some specific questions regarding your internal knowledge base. That's something that we are going to work on because that's something that increases productivity. It doesn't have direct business value, but it's easy to implement. It's in English as well. But it will show the business, look, we are capable of doing that. This works amazing. Hopefully they are all very happy about it. And it's a hype, right? So we can talk about it out loud everywhere. And then hopefully we get buy-in to do more exciting things like recipes in Dutch. So yeah, that's a plan. Thank you.
Perfect. So we have 2 minutes for one question. Someone wants to raise their hand if they have a question? Okay.
Hey, thanks for the presentation. So what model are you planning to use for your internal documentation LLMs? And how are you actually going to train that model with your data?
For the recipes, we don't know yet. Well, I'm not really a data scientist, I'm a machine learning engineer, so I'm not really busy with training the models. But we currently already have this knowledge base thing that some of our data scientists train, so we are going to deploy that. For recipes, I think it's quite complicated because you also need to have, we already have a recipe base, so you need to fit that context somehow. So we need to build this system that maybe like some graph database, you need to go in between and then feedback to extend the query. Something like that, probably. And also with recipes, it's hard because ChatGPT can come up with some recipe with 200 grams salt in it, and it has no notion of taste.
Yep.
So you need to give some ratings maybe to the recipes and maybe come up, and it's also very biased because the ratings you have, they're all very positive, like at least 3. Well, if they have no 0, it should be really bad. So you can artificially create these bad recipes with a lot of salt or something, and maybe use that as well.
Sure. Thank you.
Have a couple of more minutes.
What strategies do you employ to identify use cases, like business use cases? How do you connect with stakeholders to find those pain points?
Well, our scope is not data science, machine learning engineering, and usually we have business people that come up to us, to the data science teams, to deploy something. So we don't really, we are not really busy searching for problems. They come to us. Yeah, so we don't have the challenge really.
How do you overcome the culture that has probably the data has not entered into the overall database, and then how do we prevent that where the results constantly just perpetuating going to the English-dominated culture for recipes, for recommendations, versus the cultures that did not, I mean, recipes were not, that did not have the same access to the current database?
That's a good question. I don't have answer for that. I'm sorry.
All right. Last question. Okay, that's going to be the last one. There you go.
Thank you, great presentation. I will stick to MLOps here. So one of the issues which we face with all these LLMs and deep learning models, if you put in an app which is customer facing, the response time is not, the great. We need something like millisecond type of responses.
Yeah.
And I'm sure you also must be facing, the similar challenges. So are there any guidelines or techniques which you employ there?
Well, I think the way how people interact with the chat is very different than how they interact with regular APIs. So the response time requirements are very different because you can it can start typing like ChatGPT does. So it is in that sense less challenging, right? But you need to agree with the business what is acceptable for them. You also need to do some testing with actual users to see what is okay in your setting. And it's hard to tell before because we haven't tried that yet. So, but I don't think it's a big issue just because it's a very different way of interacting.
All right, give a big applause for Maria. Thank you so much. Next, we have Chip, and Chip is going to discuss about what's going on once I have my LLM in production, before and after the magical sandwich, including context and risk management and everything around that. If you don't know Chip, she is the best-selling author of a book around machine learning, and we are super excited to have her with us today. Chip, whenever you're ready, the stage is yours.
Nice. Nice to meet you. My name is Chip. Thanks for introduction. I'm here to talk about the LM sandwich. I know it's dinner time, so I just try to choose an appropriate picture. So it's 10 minutes. Oh, wait, how do we move? Okay, slide. So it's 10 minutes, so we won't be able to go into anything too deep. But I believe that LLM is not the everything, it's part of the pipeline. So we want to talk about what happens before and after LLM. So one thing is want to celebrate a little bit. I do think that's like the popularity of LLM made a lot of people realize a lot of things that the MLOps community has been talking about for many years. So for one thing, like you can't do AI without data. And now I see a lot of companies at the wake of generative AI try to figure out the data story so that they can leverage that data to enable new use cases. And the second is that real time is good. I think for a long time we're talking about batch predictions, online predictions, and now with LLM, everything just happens in real time, and it's pretty awesome. And of course, another is a data distribution shift. So now we see LLM and they enter ChatGPT, it's like, oh, our knowledge cutoff is in September 2021, so we can't help you answer with that. And we know that the world has changed a lot since 2021. And of course, the last one is that states matter, because now we want to get to the context, history, like previous chat. And it's not like just one-off request anymore, but we want to leverage historical information to make better predictions. Cool, so agenda, very simple. Before LLM, we have context learning, and after LLM, we have execution and monitoring. So context learning. So like a couple of questions, like for example, like so I asked a friend about whether he thinks that context learning would be here to stay, because there are a lot of questions like whether prompt engineering is hacky, or like how long we still need to do context constructions, context learning. And his response was that context learning wouldn't be relevant as long as human-to-human communication is relevant. And the reason is that like for a lot of questions, we need context to respond. So first of all, I ask you, what is the best Vietnamese restaurant in the country? And the context required would be which country, right? And if you ask into like the ChatGPT today, it was assumes that the country here is the US. But in a lot of for many cases, the default context is not obvious, and you need to tell the AI what you want. Or another question could be, how many albums has Taylor Swift released? So if you enter in ChatGPT, it might not contain or any other AI, it might not contain all the new information on Taylor Swift. So you might need to enter the newer albums as part of the context so you can answer a question correctly. So there are many use cases. So I know that you are pretty familiar with them. So for example, like customer support, like we call them like external chatbots. So chatbots that you can talk with the external users, but also internal chatbots. So like for example, the employees can talk and ask questions about the company, like, hey, I need to do these vacations. What is the policy for like vacations? Or like, oh, does the policy cover that? XYZ. So like there's a lot of like internal knowledge that you can use a chat to help the employees discover. I've got document processing, summarizations, or like storytelling, or like any task involving a lot of genes and proteins. So in this like very interesting paper, they found out that for a specific academic data set, like 16% of the questions require context to respond. But of course, I would imagine that for industry, depending on the use case, that percentage can be a lot higher. And here's another, you can see this people talking about context length, because I choose to input context into the prompt, it might take a lot of input tokens. And here's an average for some of the tasks. It can go up to hundreds of thousands of tokens, which also means that context length will be a key challenge for the future AI use cases. So here, traditional ML and the LLM workflow changes a little bit. So one thing is that for traditional machine learning, you get users using the applications, and it might create a prediction request. And then you might also tap into the internal data to get the feature extractions so that it can input into the model. So here the input into the model would be features, so the model can make predictions. However, for LLM, it's almost similar, but there are two key differences. So one thing, the input into the model would be the prompt, which could contain the context, and we need to construct the context from the data or other historical conversations. And then it's not going to be one-off prediction anymore, but for each response, for each prompt, it would need to pull previous conversations as well. So we can see this after the LLM output a response, it would go back into as part of the context for the next question. And I also think about I added a low latency data pipeline, because for traditional ML, you might be able to do that in a batch phase, but for LLM, everything is pretty much in real time. And you want to do things as fast as possible for the users. So here's an example for the context needed for customer support. So here's a use case, it's an external chatbot. So say I'm an user and I want to like change the shirt I ordered yesterday from size M to like L, right? And here on the left, you see like the kind of data that chatbot might need to respond correctly. So first of all, the first thing it might need is like to get to pull out the customer identity. So you can respond like, hey, Sarah, let me look into this for you, right? So you need to know who you're talking to. And then you might need to look into this customer recent orders. So like, maybe that person never ordered the shirt. So you need to double check that to tell that like, maybe like if that person really ordered a shirt, and you might want to confirm that with the users. And then you want to check into the order status, because if the order has already been shipped, then there's not much you can do about it. You can tell the users like, okay, it has been shipped, so now you can return it and order one later. But if it has not been shipped, then maybe there's some room for you to do about this. And of course, you need to know inventory, because maybe the size L is not available anymore, and you might want to recommend other items. Like, okay, I know that for this shirt, there's no size M, size L, could you be interested in other shirt based on your preference in the past, or like other users' preference? So like, there's a lot of information that you might want to pull on from your database to have the AI like respond to the users effectively. And a lot of that would need to be pulled in real time, because you probably don't want users to wait for like 5 minutes. So context data can come from multiple sources. So a lot of them, like people talk about like vector databases a lot, and it's definitely like going to be here to stay. And vector database is not something new, right? Like I think it has been around for like many years, for like almost a decade. And like Google has Scanned, Facebook has FICE, and they own very good vector databases. So they're not new. They've been around for a while, and I think they will continue to be very important. So they are really good for unstructured data. So you can chunk them and get embeddings and store them. But you also need you also need them for structured data as well. And you might want to access them from a transaction store and like streaming data like Kafka, Kinesis. And we said like here's a low latency, but latency requirement really depends on use case. And if you don't have a strict latency requirement, then there's a lot of room for you to design the data pipeline. For example, if the user is okay with like 10 seconds, then you might still have time to go into Snowflake or S3 to be able to query and retrieve the data. But if our latency is like a second or like 100 milliseconds, then you might need to like store everything in fast storage or like hot storage. Like you might need to go to like Redis or Cassandra or Postgres, which can also be very expensive. And of course, there's a question of like security. So you need to make sure that the employees or like people who use a chatbot don't accidentally include personal or sensitive data in the context and send it like outside, because it might be violations of like compliance. So it's actually a very interesting thing. I'm not sure how you guys, if you here have experiences, but I see that a lot of companies, a lot of managers I'm talking to are worried about their teams using LLM without reporting like how they're using LLM. So like I think like there's some crazy number. You can probably like look into research about it, but there's crazy number of people who have no idea how the employees are using LLM, or just like copy and paste any document into like ChatGPT and see what responses get. And it's really not kosher. Anyway, and also you might want to like detect and block on the request that might contain this information. So say that you might have some kind of like check before you sending out the API request and say like, okay, does this contain like PII or personal or like sensitive data? And if so, like what could be the appropriate action to do that? Like do you want to block it, or do you want to flag someone, or like what action do you want to take there? So I would say this like context learning is actually a data engineering problem, because it deals with data retrieval, data governance, and also like latency optimizations. Cool. So here I want to plug like Claypot. We do like we are pretty much a data product. So we deal with anytime when people have latency or data retrieval problems. That's where we are. Okay. So like after LLM, it's going to be executions, and that also involves data. So let's say the chatbot has successfully updated the order from like size M to size L. Now someone had to execute it, right? Like it had to like alert the appropriate people like who is involved, so that maybe there's an actual warehouse employee or some warehouse robot who actually do the task of like swapping out site M for site L. And of course, you want to might update on the databases. First, you might want to update the auto databases, or you want to update the inventory database so that you can like maybe remove on site L and like add back on site M. And after that, you might want to like monitor like LLM responses. So I think like there's a lot of research today like to try and understand the level of risks that LLM pose to a business. So one thing is definitely like brand risk. So for example, like it might output like very racist or sexist content, or it's just like badmouth your brand or like badmouth your competitors, which might not be a good look. And of course, you might want to detect like if maybe the LLM might accidentally reveal sensitive or personal data. For example, there have been like a lot of people trying to jailbreak AI LLM to make it return like phone numbers, social security number, email addresses, or like other private information, which you might want to detect and block. And of course, like you might want to like gather user feedback to improve the LLM. And also like a very big question I get a lot when I go to talk to different companies is like what to do about hallucinations. Like what if the AI just make up stuff and just like, it is like a very challenging problem, and I don't think it's like the concrete answer, and definitely not something we can cover in like 10 minutes. But anyway, that's my talk. Thank you very much for your time, and feel free to reach out if you have any questions. Here's my email, Twitter, LinkedIn, and also very active on Discord.
All right, we have a couple of minutes for one question for Chip. One question, if you have, you can raise your hand. Here you go.
So these most recent slides, are they going to be on your blog, or are they in the book?
It's not my blog, but I can send it to you.
Okay.
Yeah.
Cool. Thanks.
Chip, thank you so much for everything. I'm sure everyone learned a lot. Give Chip a big applause. It's really interesting to start with MLOps, LLMOps, and then discussing what's actually happening with our data and how machine learning and LLM is impacted by our data and security. And so with that, I'm very excited to bring on our next speaker. Hi. So Jerry is going to speak about data consideration for building more production-ready LLM applications, and is going to share a lot of insights on that topic. So, Jerry, the stage is yours.
Hello? Cool. All right, I have 10 minutes. So hey everybody, my name is Jerry. I'm the co-founder and CEO of Llama Index, a popular open source framework to build LLM applications over your data. And today I think the topic that I want to discuss is just like, it's practical data considerations for building production-ready LLM applications. So kind of moving a little bit beyond some of the super simple stuff into kind of like some of the more advanced stuff. Okay, how many of you guys are familiar with retrieval augmented generation as a term? Okay, so let's start from the basics. Let's say you want to build an LLM application over your data. This is typically the stack you do to build an LLM kind of like system and like build like a QA system using a large language model over your private data. So you start off with some like source documents. You want to chunk up these source documents into a set of like text chunks and then put it in like a vector database, like a Pinecone, Chroma, Weaviate, Milvus. And then once it's actually stored in the vector database, you have like a query stage where you do some sort of like retrieval and then querying on top of this data. And so basically you retrieve this data from the vector database and then you feed the chunks into the language model as part of this thing called like in-context learning so that you can actually synthesize a response using the language model. So this I call like the naive RAG stack for building a QA system, because this is like probably the most basic thing you can do. If you do this with like Llama Index or LangChain, you can basically do this on like 10 lines of code, right? It's pretty basic. So kind of going into this a little bit more, the naive state of like data ingestion and parsing is that you split up documents into a set of like even chunks, The chunk itself is just like a text block, right? It could be split by sentences, characters, those things. And then all these chunks are stored in the same collection in a vector database. And then during query time, you use embedding similarity to find the top k most similar chunks from the vector database collection, and then you plug it into your LLM, like do response synthesis over the data to get back an answer. Okay, so if you've ever built this type of system before, you know that like a lot of times it doesn't actually give you the best response. And when retrieval augmented generation fails, the most common reason is that the retrieval system is bad. So if the retrieve results are bad, like even if you have like GPT like 20, there's no way the LLM can synthesize like a proper response without like hallucinating some sort of information, because it doesn't know anything about the retrieved data because your retrieval system didn't actually give back the right data. And so the most common retrieval method these days is like top K embedding lookup. There's some causes of bad retrieval quality. Each chunk that you split from the source document does not have awareness of the parent context or related context. The query itself might be kind of complicated, and it might assume like you need to kind of traverse your documents in a certain way that like top K embedding lookup doesn't actually do. And then the data might also, you know, if you have multiple versions of the data, it might be like redundant or out of date. There's also like practical system level considerations with this stack, because like this basic thing is pretty easy to set up for like a hackathon project. But then like, let's say you want to deal with like updates in the source document. How do you actually propagate updates from your source document into your vector database or into any other data collection that you store in terms of like the chunks that you store in the database? How do you adjust like chunk size over a large corpus of data? So there's a lot of like system considerations if you're trying to actually productionize one of these LLM powered applications. So one of the key lessons here is that if you want to improve your retrieval augmented generation stack using LLMs, you want to improve the way you handle state and not just the retrieval algorithm. And that's kind of like the purpose of the talk today. And really just like the higher order bit is just like, if you want to build an LLM system over your data, you kind of need to take into account all these considerations if you're going to build a production quality application. The first point is augmenting chunks with context. So one of the reasons like embedding-based retrieval fails is that like the relevant context chunks don't actually like match the query embedding, because they lack like global context about the kind of like about like what the entire document is about. So one thing that you can do is actually inject metadata into each text chunk. Imagine like the GPT-4 like archive paper. You split it up into a bunch of text chunks, but then, you know, like maybe for each one, you append metadata, for instance, like the page number, the organization, those things. And then you inject this metadata into the text chunk. Now when you actually do retrieval over the system, the embedding-based lookup can utilize the fact that there's metadata, you know, in these text chunks to actually kind of do similarity lookup and pull relevant information. The other bit is it's nice to kind of actually explicitly define node relationships within your data. So if you have like a text chunk right here, it might be good to define, hey, this thing happened after this thing, and this thing actually happened before this other thing. And then this thing is actually a subcomponent of this overall thing. And by defining the state, you can actually design like a better retrieval system over your data, so then the LLM has enough context to kind of not just exploit the current information, but also exploit relationships within your data so that it has more information in general when it actually tries to synthesize a response. Here's a very simple use case, right? Let's say we're kind of asking, yeah, this is like a question over, I think, a Uber like SEC filing, like what was the impact of COVID, and show the statements in bullet form and then also show page numbers. Obviously, if you just split the text by itself, each chunk is not going to have knowledge of what the page numbers are. But if you actually just add page numbers as metadata to each of these documents, you can actually get kind of like, you know, you basically inject the metadata as like a annotation, like page label 6, page label 18. Then when you actually create this overall system, you can ask these questions where it can actually cite the page numbers given the context. Cool. That's just one of the steps. I actually don't have too much time, so I'm just going to kind of go through the higher order idea of a lot of these things. The other thing is just like pick a good parser. You know, sometimes there's a lot of like these different types of text splitting strategies when you break down a document into a bunch of chunks. There's character splitting, there's token splitting, there's sentence splitting. There's a lot of like out-of-the-box file parsers. There's a company called like Unstructured that builds like really nice kind of in-house native parsers over different file formats. But like for certain use cases, you might have to inevitably write your own parser. So for like an SEC document versus like a Supreme Court filing versus like an Instacart web page, these are very different kind of data representations, and you're probably gonna in the end have to do something custom for each one of these. The next piece is like being able to define the right indexes over your data. So can you tell me about like Google's R&D initiatives from 2020 to 2023? I guess like the higher order idea here is that putting all the chunks into a single collection and not separating the documents in some way will probably lead to pretty bad results. Because if you ask this question, and you ask a question like this, and you say like fetch the top 4 most similar chunks from the vector database, you're not really guaranteed to get back specifically, hey, the R&D initiatives year over year, right? You're probably gonna get back like a bunch of random chunks. Some of them might be 2020, some of them might skip a year entirely, some of them might be like 2023. And so the idea here is that like by defining some sort of structure over the way you actually store the data, you can actually inform the retrieval and actually get outputs in a more structured manner, right? And so if this is getting a bit technical, the key idea is like you kind of have to think about this when you're actually building this like overall question answering system of your data, right? It's not just like as simple as, okay, I'm just gonna throw a bunch of stuff in a vector database, ask a question, and it's gonna magically work, right? These are all things you kind of have to think about. The last thing I'll probably talk about is if the source document changes, you kind of need a way to like update the nodes in the vector database. For instance, like let's say this document is like a web page and there's like an edit attached to it. Or this is like a patient history and all of a sudden it gets updated with new information. You can choose to do some sort of batch update. You can choose to do some sort of like rolling, like a trigger-based or real-time update. But ideally, every time you do this, hopefully you don't need to re-update the entire collection. So if you go from a source document into your vector database, you probably need to have some mechanism to like sync just the relevant changes. So, you know, this is again a bit technical, but like if you just maintain a hash for each document and kind of like hash the context, and then you maintain a mapping from like the node doc ID to the source doc ID, if the document hash changes, you can basically kind of say, hey, I know this document has changed, please update all the nodes in the document ID with the same document ID with the new content, right, and try to re-embed everything. So that's basically kind of like, these are all the problems that Llama Index tries to solve, right? And so we try to do not just like the simple stuff, which by the way, if you try this out, you can like do the simple stuff in like 3 lines of code. We try to really think about the advanced stuff too. And so these are all kind of like data considerations that you kind of have to think about if you want to build a production-ready LLM system. Cool. I think we're going time.
That's okay. All right, questions?
Hi, so just for the example of the Instacart webpage, let's say I have description of, okay, let's say you go to an Instacart webpage for like vegetable juice, for example.
Yep.
If you have like a description of the vegetable juice and the nutrition facts, what is the thought process? Because question answering is a typical NLP task. So how would you think about whether to just use some question answering model like as you would treat a regular NLP question answering task versus using this RAG stack?
I see. Are you, I guess like, I guess one bit of this is like, should you use like a language model, right? Like
Yeah.
the idea of like a large language model is that it has some sort of like big context window that you can try to like put stuff in there, right? The other option, of course, is like, I guess part of what you're getting at might be you can try to like tune the model itself so that like the model itself can internalize a bunch of information. I think these days with large language models, probably the more popular approach is really just like using the model as is and then actually trying to like fill in the input prompt with a bunch of context. And I think part of this is like creating like a good data pipeline so that you could actually fill the prompt with the right context given that the model is fixed. Yeah. But I think, yeah. Yeah. Oh, I would actually argue if there's not, so the question is like, if there's not that much data, is there value in kind of using a large language model? I'd actually argue, yeah, I think if there's not that much data, it actually, then you can kind of like exploit the fact that there's like this input prompt space that you could put stuff into, right? Basically, you just like use the input as like this cache space so that it can just like internalize and reason over new information. Yeah.
So I have a question. So I want to confirm, basically you're using those contexts as the metadata for filtered query, right? To improve the search relevance of the answers being returned. So how do you determine what context should be indexed as metadata in your system? Because for so many different type of data sources, there are so many different ways for you to define the metadata. So I think that might be a challenge.
Yeah, so that's actually a great question. I honestly don't have a great answer to that. I guess part of the point of this talk was also just like, you should think about it and it should probably be domain specific. And so like if I've talked to like a few kind of customers building different types of applications. So if you're building like a legal chatbot versus like building a e-commerce like shopper, the type of data and the type of metadata you're going to have to inject is generally going to be different. I could imagine like, as the months go on, there'll probably be some sort of like best practices for like, for like PDFs, you generally should put like page numbers and the title and that type of stuff in there. But I think right now it is very like data specific, right? Like PDFs, page numbers definitely, the title definitely, but like other stuff, like it's probably a little bit specific to the case, the kind of like problem statement that you're trying to solve. Yeah.
Thank you.
All right, thank you so much. Please give a big applause.
Cool, thank you.
Thank you. It was great. Wow, so we had a lot to unpack today, starting with ops, moving to data, moving to how to better work with data and index it to make sure we have the right context and the right state. And now we're going to have a session about how to deliver safe and effective LLM applications using the open source NLP test library by David Talby, the CTO at John Snow Labs. David, the stage is yours.
Thank you. Hello, everyone. Finish with that. Yes. So what I'd like to talk to you about is responsible AI and an open source library that you can use today to evaluate LLMs, compare them, and make sure we get to production safely. Responsible AI today is not optional. It's not a nice to have that you have on top. Most of my work is in healthcare. Generally in healthcare and life science, it is illegal to go to production like with one patient or one customer before we actually proved in writing and validated that you're not going to hurt someone. But even in other area, we have cases. This is now, people are being sued as we speak. Whether you are in e-commerce, you cannot offer different prices to white people and black people. Same thing for recruiting, consumer protection, banking, credit decisions. You need to be able to prove that you are doing things correctly, that you are not violating laws that are already existing to protect the populations. So in order to, to tell the world that everything is okay, basically every company, every large company came out with this beautiful graphic that says, our AI, it's ethical and it's human-centric and it's responsible and et cetera, and very quickly we had more of these. And then we had more of these, and really there's no large company or consulting company or government organization does not have one of these like beautiful things. But the problem is, what do we do when we actually go and implement a system? And if you read just about every paper that comes out on the topics of robustness, bias, fairness, toxicity, truthfulness, data leakage, what you find is basically, and this is, by the way, the same thing I'm seeing right now kind of in practice in production, the situation is really, really bad. You take a prompt, you change one character, it breaks. You test it, males versus female, white people versus black people. You look at data leakage, you try to protect the information, you find it. The one thing that's common to many of the papers of this year, all of them say, here's what we found, and in the discussion section, this is really not surprising because we are the first ones to ever check. Okay, and what we need to go really beyond that step now. So here are some things that we have learned that you need to pay attention to when you deploy systems. So here, things that you need to do. First of all, you need to actually test your models, whether they're classic ML models or LLMs. So really right now, especially with LLMs, we are kind of where we were with software engineering in the 80s. I code the thing, it sort of works on my machine, okay, push it, right? And then we learned that there's this whole theory and practice of software testing that goes through many, many layers and has many, many tools so that we actually know that when you say something works, it actually works. And now we're at the point where we need to do this. And if we don't do this, really, there's no surprise that the situation as it is today. The other thing we need to do, which also is obvious once you write it, you have to test beyond accuracy. Okay, if you want a system to be robust, right, to be able to deal with typos, right, or the fact that you change the order of words, if you want it to deal with bias, if you want it to not leak protected information, if you want it to not be toxic, you actually have to test for this stuff, right? And just like we have unit testing with every version before it goes to production, you need to know that you're safe. There are two important things that we've learned that you cannot do, because we actually deploy this for real customers and get feedback from them. The one thing you should really never do is pick a model that someone published with a paper, someone published a checkpoint, kind of said, this is my model, it has the best F1 score, it's really great embeddings, I'm just going to go with it. Okay, basically we find these models, usually they perform okay on the F1 score, not always. Generalization is something to usually test. But in general, the current standard on how they perform on any other requirement and any other metrics you look at would be far below what you'd normally expect. So that's one thing I can tell you, just never do this. The second thing you do not want to do, you do not want to rely on standard benchmarks. Okay, so if you know, for example, Stanford, they have a great project called the HELM, Holistic Evaluation of Language Models. There are lots of benchmarks for toxicity, for truthfulness, and there are two problems with it. One problem is what a lot of companies and systems do today. They do what's called classic overfitting. They train the LLM on those tests. Okay, and then what you get, of course, you perform beautifully on the test. Yes, you test on your training data, that's fantastic. And really, then what you say, like really change one word in the prompt or one word in the data, and then the thing completely fails. The other thing that you get is really general robustness issues. Okay, and really I have an unproven hypothesis that a lot of the gains that we see now with very large language models compared to the same models, 500 billion parameters or 50 billion parameters, is really the models that just memorize more of the web. Okay, and if you give it a medical test or a legal test, it's just very likely they actually have the exact copy of the same test and it can just give you the answer. Which is not what you want to see when you want to have a generalized model. So to deal with some of the issues, one of the things we've done at Johnson Labs, we've built the NLP test library, and this is completely open source. It's Apache 2.0 license. Use it, abuse it, take it, do whatever you want with it. It's open for commercial use. The goal is to have something that's very simple, so as you'll see in a few lines of code, you can tell it, please generate tests for me, and right now there's, I think, about 60 plus somewhat types of tests that it can generate automatically. You can also do things manually if you want to. Testing also is something that you don't need to be a data scientist to do, right? You really want to be like really an end user or kind of a domain expert to be able to come and say, here's how I test something, just like classic software testing. We want it to be comprehensive, so actually test in one place everything that you want to test before you're ready to go to production, and of course make it open source. So the NLP test library does three things for you. So instead of the current path, which is you train your model, accuracy looks good, F1 score seems to be stable enough, push it to production. We want to add 3 steps. We want to generate some tests. Then we want to run the tests and get a pass-fail score, right? And this is something we need embedded in our release or MLOps pipeline. And in some cases, we want it can also do some data augmentation, okay? So that we can automatically add more training data and improve the model. So let's see how this looks like in practice. So these 3 lines of code show you really the whole thing end to end. From NLP test, we import the library. Then we create a test harness, which is an object, and you basically tell it, look, I want to test this model. In this case, we're testing the most widely used model on Hugging Face, or a BERT-based case, from Hugging Face. You can also specify the tests that you want to use, but there's a default test set for each task. So whether you're doing NER, or you're doing classification, you're doing question answering, you're doing summarization, they're kind of standard test sets that you start from. And then you use the harness. So you tell it to generate tests. Okay, which means start with the test set that I gave you, but it's a kernel. Generate other tests from it, and we'll see what kind of test you can generate. Once you generate the tests are just available as a Python data frame. You can export them as a CSV, you can edit them in Excel, you can load them, you can do whatever you want. Then you run the tests, okay, meaning actually run inference and see if each test passes or fails. And then just generate a report. It gives me per category how am I doing for each kind of test, and in the end, based on the config file I provided, did I pass or did I fail? In terms of what you can test, kind of the hubs you can use, so this is what's available right now out of the box. So you can test any Johnson Labs model, any Hugging Face model, any OpenAI model, anything that works with LangChain, Cohere, Open Assistant, AI21, OpenAI, of course, all the Llama and Llama variant models, so all of those are there. So those integrations are there, and also the way just the system is designed, if we add another kind of hub or another source of models, all the tests work. We can generate and run tests of all of those. And also if we add another test type, so for example, we recently added the toxicity tests, so now we can do toxicity tests on all of these together. Okay, so it's designed to separate those two concerns. And now let's talk about what you do. And the first thing you want to do is actually generate tests. Okay, and what I want to explain is what this means. So robustness tests basically want to show how your model performs if you make small changes to the input. So what happens if I introduce typos, spelling mistakes? What happens if I change the speaker? What happens if I change the time, right, from present to past? What happens if I add punctuation? What happens if I change a question to an answer or an answer to a question? Okay, can you still answer the question? There are different types of fairness tests. Okay, the simplest one would be, classify whether this is talking about a man or a woman. Then I want, for example, whatever accuracy metrics is, let's say F1 score. I want it generally, here's the minimum I want, that's a test. I want it only for male, it needs to be at least that. Only for females, it needs to be that. So that's kind of your basic fairness per group. There are different types of bias tests. And this is where you'll see a lot of things really failing. For example, names. So really, when we started the project, we actually had a real customer, and we were doing medical data de-identification, anonymization, and they let us know that, look, if you type in, Mike Johnson came and complained about, knee pain, it worked 99% accuracy. If it was an Asian name, like Wei Wu came and complained about knee pain, it was only around 91% accurate. Okay, so really it means made like 5-6 times more mistake, okay, with this group. And then when you look at this, you come and say, okay, it's a bug report, but really, first of all, okay, shouldn't we also check, white people, black people, Hispanic people, Jewish people, Muslim people. We have now tests here, for example, of Hindu people per caste, okay, because they're typical name per caste. We have first name, we have last names, so we can automatically do the kind of generation. As you can see, on countries, we replace countries automatically, and there's UN lists of countries that are kind of richest, poorest, and then there are 2 more classes in between. We can look at it say per age group, per religion, and there are other tests that look at kind of specific biases, like young, old, rich, poor. Basically, you can add adjectives automatically, so those are some of the other things that are there. And then there are accuracy tests, okay, because if you comprehensively test the model, yes, you also want to pick the most accurate model, or at least you have an accuracy baseline before you go to production. So we've implemented all the metrics around, your classic summarization metrics, question answering metrics, that's there as well. And we have representation tests. Okay, so for example, sometimes you can say, oh, I want the accuracy for women only to be at least 90%, but there's another thing. Sometimes what you find is you have a protected group and you don't even have 10 women in the test set, right? And you can say, look, I'm just going to fail this on just lack of representation. Okay, kind of go and work your tests as well. Overall, there are 10 categories of tests that are there. When you run the test, let's say you can generate the test and either automatically or you can edit them manually. And you can see the example here. So in the first row, we've added a typo. In the second row, we've added just some context, some hashtag. In the third row, we replaced kind of the name, right, to another ethnicity. And the other 2 rows, we look at representation and accuracy. Usually, even if in a simple case, once you generate a test, you can have really from a few hundred to a few thousand tests. Okay, and really the nice thing that's different from just unit testing on software to this is now we can actually generate a lot of these. And you can edit it, you can play with it, you can do whatever you want, you can save and load those tests. And then after you call run, we run the test, we run inference, and you call report. The report basically groups everything by category. And then in a config file, you tell it, okay, from this category, I want a minimum of 100% pass, 50% pass, 80% pass. And it tells you whether you passed or fail. Okay, and this is something you integrate as part of release pipeline so that every new version of the model needs to pass all the tests like any other piece of software. Okay, on top of that, if a regulator comes and says, oh, well, why do you think that this model is not biased? You can tell them, I'm happy you asked. Here are the tests, and I can give it to you as an Excel file, right? You don't need to be a data scientist. Here are all the things of tests. Here are the benchmarks. Here's my release process, right? And I can show you that at least these baselines are being met. So you can generate tests, you can run tests. The other thing you want to do is data augmentation. Because if you think about it, look, if you can generate new tests with Hispanic names, black names, female names, first names, last name, country names, and you can show that the model is garbage or does not do as well, well, the next thing you can, okay, well, if you can generate all them, can you just add them to the training data and just retrain with that and give me a stronger model? And that's what augmentation wants to do. The only thing is what you cannot ever do is take your tests and use them to train the model because that is classic data leakage, right? You cannot then test on what you trained on because then of course it's going to do better, right? Yes, I trained it on the test material. So what age.augment does is it generates new examples only on the training data. So if you see here the example age.augment, you give it your training data set, okay, not the test, it's separate. It generates new example and you tell it where it needs to send the output. Okay, so I generate a new enriched augmented training data set for you. Then you train a new model and then you can do whatever library, whatever, however it is you train or tune your model, that doesn't matter. And then what you do is you run a regression test. Okay, which means that I want to create a new harness with a new model, but I want to load the old tests. Okay, so you have that one-liner and then you just call .run and it does that. Okay, so that's basically the workflow here. And what we found is, especially on robustness and sometimes on bias, this is actually enough to solve quite a lot. Assuming, of course, that the protected groups really behave similarly, right? So it's really just a matter of text. What you can do now with this, we have been working on this for a few months now, including kind of real production use. I would say things to know. Right now, if you look at the current LLMs that are in the market, the baseline is very, very bad. Especially robustness, fairness, and bias. Situation is not good. If you're working within any regulated industries, please test what's going on so that you're not in a position next year or the year afterwards with people rightfully sue you. Okay, so at least you should test whether your stuff works. This is completely open source. We build this for you. And we use it internally. We have a full team on this. One nice thing with Johnson Labs is that we're not, we're profitable, VC funded, just like this is our third open source project, so we know we can support it for several years. It's not depending on a grant, it's not depending on funding, it's not depending on anything. So we're committed to open source community, just like our other projects, to do this for the long term. And with that, thank you, and I hope you find this useful.
David, thank you so much for all the exhaustive capabilities and abilities for us to take advantage. Maybe Jon Snow knew nothing, but Joe Snow Labs definitely know their things. So that's very exciting. We have a couple of more minutes for one question. Okay.
Hi, so I work in AI ethics, and I wanted to ask you, you said don't trust the benchmarks, don't trust the model out of the box, but trust me. So, why should I trust you, and why should I trust your tests? I just want to know.
Oh, no, definitely do not trust me. I would not trust me.
Okay.
I don't know anyone. No, actually, my kids, no, forget it. No, this is an open source project. Okay, what you do here is you generate your own tests. Okay, so what we're saying, for example, you start with a question answering data set. Okay, usually if you take that, any of the data sets on Helm, you just run them, you're going to see better results than what your customer will see in practice. So here's what you should do. You can start with it, generate more tests with it. Okay, try different variation, try to break it in terms of once and try to see what happens. What I see is that often once you look at the bigger data set that you've built, right, nothing I did, right, you'll see that the results are worse substantially than what you'd expect in terms of ability to generalize, ability to really handle what you think would be trivial changes in code. And then you can tune your models, you can augment your model, you can fix that. I would say we do work in healthcare. Another thing we often do is we generate the tests, then we have medical doctors look at them, okay? Because some of the tests they can say, oh, this doesn't make sense, like this will never happen. Some that says, oh, this is great, I want to add 10 more like this. So you can see them go in Excel, or they paste, they come and say, oh, try all the medications that are, don't done as pill, right? Like, all medications or devices, right? Yeah, because you present it differently, the dosage is different, it's gonna break. All I'm saying is, if you only rely on the standard academic benchmarks, okay, I think you'll be overly optimistic, okay? And I think really, and the main thing that's happening right now, I think really is overfitting, right? Because really right now, like if I want to show that my LLM beats all the academic benchmarks for healthcare, it's super easy. I just train an LLM on them, or tune an LLM on them, right? And it's going to do beautifully because it does a lookup, right, essentially.
All right, please give a big applause to David. Thank you so much for sharing your knowledge with us today. Next, we have Frank, Director of Operations and ML Architect at Zillis. And Frank is going to talk about how to work with exponential search, long context models, where the length is longer than 100K, and we need to parse and work and maintain context about all of them. So Frank, please go ahead.
Thank you, Eddie, for the introduction. I know we're running a little bit short on time here, so I'm going to try to keep this nice and sweet. Short and sweet, excuse me. So today the topic of my talk is about vector databases in the context of, in the era of large context models, right? Quick introduction of myself first. My name is Frank, Director of Operations, ML Architect at Zillis. So I do everything from loading the dishwasher to training ML models to supporting some of our users. And a bit about us first. We are the company behind Milvus. Milvus is the world's most popular open source vector database. And we just passed 20K stars, which is a bit of a landmark for us as well. We're headquartered in the SF Bay Area, and Zillis Cloud, which is our managed service, is based on top of Milvus. So you get the performance out of Milvus in a managed service. So I'm going to split this talk really into two parts, right? And the first part is probably going to be a little bit more geared towards ML folks. I'm going to talk about some of the tricks that we use to get to long context, some of the tricks that Anthropic has used to get to 100K, OpenAI has used to get to 32K, and probably beyond that right now as well. And then the second part, I'm going to talk a little bit about vector databases, right? How do these long context models impact the use of vector databases in production? So just kicking things right off, right? One of the simplest ways that you can actually achieve these long context models is actually with something called sparse attention. And the idea being that regular attention is n-squared complexity relative to the number of tokens that you have. So the capability to say attend to fewer tokens earlier or after, if you're using mass language modeling, is a powerful way to simply reduce the computational complexity for a large language model, right? At the same time, you have what I'll call a little bit more low-level optimizations. So flash attention in this case is a way to actually prevent or not make it unnecessary for you to have these very, very large matrix multiplication instantiations. I won't go too much into the detail of flash attention, but it's one of the ways, a little bit closer to hardware, a little bit closer to the register level, that you can actually use to get that long context. Better positional embeddings, right? So there's some very, very unique ways for you to be able to, let's say, pre-train on very, very short context, and then fine-tune on much longer context. And diddling with the positional embeddings, again, I won't go too much into the details here, is one of the ways that you can do so. And then reducing memory requirements as well, right? So even though pre-training is great, right, we still, if we're using just standard commodity hardware, we want to be able to train these very, very large models, and we want to be able to do so efficiently, right? So LoRa and some other methods out there allow you to adapt your weights and allow you to, let's say, have much, much better, significantly reduce memory consumption from that perspective. And then, obviously, another one is just simply buy more GPUs. And one of the jokes I've seen on Twitter is that, startups these days in 2023 as a way for VC money to exchange hands using startups as a middleman to NVIDIA. But
in this particular case, it actually really is true, right? So if you really do need to be able to run those large context length models, buy more GPUs, do everything from a scalable perspective, scale out vertically. So that brings me to part 2 of this talk, right? And I'm going to talk a bit about, are vector databases still relevant in this particular era, the era of long context models? And I think the answer is a little bit both yes as well as no. I'll go over some instances where you might still want to use a vector database and other instances where you might not, right? The first example of when you might want to use a vector database is if you have lots of documents or you need some form of persistence, right? So even though 100K tokens, like what Claude can provide, it is a lot, but sometimes you'll easily be able to exceed a lot more of it. So a lot of our users in the Milvus community in particular actually scale up to 100 million, even 1 billion documents. And this is not something that's going to fit even in a very, very long context length model. If you need high throughput or low latency applications, using a vector database can help you minimize costs. And on top of that, LLM inference, I think, is not cheap when it comes to runtime as well. It's going to be able to speed things up for you significantly. And the third and final one, the third and final point for when you might want to use a vector database is if you want to do more customized filtering, right? So let's say you're using Llama Index and you want to be able to do something not just over vector fields, but also over metadata fields or scalar fields as well. Sometimes that particular capability can be built into your vector database, as it is in this case for Milvus. And then some examples of instances where you won't want to use a vector DB, right? So if you have very, very few documents or you don't have too many document chunks, I would say just skip that step, right? Oftentimes I say if you have fewer than 10K documents, you can do something very simple, do some very simple filtering and be able to get the results that you want consistently as well. If you have very, very interdependent documents as well, so if a lot of your information is stored across multiple documents or potentially across multiple chunks, and doing that chunking or taking up a chunking strategy is not going to be ideal for your particular application, I would say skip the vector database step as well. And the final one is if you want precise results at cost of higher accuracy or at the cost of simply a little bit more runtime. So again, those are the two instances. Those are sort of some, I think every application is a little bit different, and there's never one great solution as to, hey, do I want to use a vector database for my LLM application or not, right? It really depends on a lot of the context. So that is the end of my talk, and I'll try to keep it pretty short and sweet here. I'd love to take some questions from the audience if there are any.
Hi, thanks for the talk. So I have a question about, there's a blog on x16z and also a post on Hacker News that compares like different vector databases in the LLM architecture space. So I'm just curious, what's the advantage, or how does Milvus differentiate from the other competitors?
Yeah, that is a great question. Let me see what post you're referencing. Give me one moment. Sorry about that. I think it really helps to understand sort of what are you referring to this one right here? Okay. I am not going to respond to this particular comment, and the reason is because I think whoever posted this is clearly trying to bait me or someone else from the Milvus team into saying something bad about these other vector databases, right? And quite honestly, I have nothing bad to say about any of them, right? On every single day, right, I learn from a lot of these other vector database communities. In particular, Weaviate, I think, has built something very, very unique and very, very solid around their product, around their platform, and I learn from them every single day, right? I've been incredibly impressed with the amount of hype and the amount of noise that Quadrant has been able to generate in a very short amount of time, right? And at the same time, Vespa, I would argue, even though I represent the Milvus community, I represent Zilliz, here I would argue that Vespa is even more advanced and more feature-rich than Milvus, right? So I really have nothing bad to say about any of these folks. But what I will say is that we view a lot of these other vector database companies as allies, as friends in this fight against vector database pretenders, folks like Vertex AI's Vertex AI's matching engine, folks like AWS's OpenSearch, right? We believe that purpose-built is the way forward, and we find a lot of these other communities as folks who really, we can work together with. So I don't know how a lot of these other companies, well, I know how Pinecone feels. I don't know how a lot of these other companies feel, but I hope that they feel the same way. Great question, though.
I was just wondering if any of your customers were using you for semantic caching, or is that not a use case you're seeing yet?
Yeah, great question. So I think what this gentleman here is referring to is we have another project in addition to Milvus called GPT Cache. And what that is a semantic cache for LLMs. So let me pull that up here. So also under the Zillow's repo, GPT Cache is meant to be, if I can actually pull up a code example here, I think it'll be a little bit easier to understand. I'll actually pull up this diagram here. But LLMs are often I think they can be pretty expensive to run, and also the latencies can be high, and that's really where having a semantic cache can help. Oftentimes you want to be able to store things semantically using a vector database and to be able to retrieve those results and serve those results to the user rather than having to bounce everything out of an LLM. Does that sort of answer your question, or do you have something a little bit more specific? To using a semantic cache, right? So we have folks that are actually using GPT Cache for POCs. But in terms of production right now, maybe there are some, but if there are, not anyone that I know of. Great question.
Any more questions?
A lot of the tutorials that I've seen using vector databases to help with search focus on embeddings only. Have you seen any customers that use LLMs to help synthesize faceted search on top of just using embeddings?
So to clarify your question, could you clarify your question about faceted search?
Yeah, so searching through structured fields, like if you're doing product search, using explicit tagging and faceting on that field, in addition to just doing semantic search.
Yeah, great question. I actually am going to, so I think Jerry gave an awesome talk about LlamaIndex a little bit earlier. And generally the way that we actually see multiple sources of data combined, both inside and outside of the Milvus community, is using one of the connectors like LlamaIndex or LangChain or some of the other connectors out there as well. When it comes to vector databases, it's generally only for the vector, the semantic component, or for the vector plus the metadata or scalar fields. That's what we typically see. But great question as well, right? So there are a lot of examples where you would want to take data outside of that vector database in more structured fields and be able to input that into your LLM as well. But that's generally how we see folks do it. Either they'll do something custom or they'll use Llama in conjunction with Milvus.
Cool. Any more questions? All right. Oh.
How can you store tables in databases or query from tables? Like the vector database can store text, raw text, but in some SEC documents we have tables. So can we store tables and query from them? Because they are tricky because the arrangement messes up.
Yeah, that's a great question. And the typical answer that I would have for folks who are looking to store data in a more structured format, there are two ways you can do it, right? So there are ways to vectorize table-based data as well. And then the other way is, as I mentioned a little bit earlier, where you can actually store that table-based data in a more structured format in something like Mongo and be able to retrieve those results as well. So those are the two answers that I'm going to say. Probably not 100% answering your question, but those are the two common use cases that we see in the Milvus community. The first, again, is to actually vectorize that table and store it as a completely separate document or document chunk inside of your database. And the other one is to simply have that data externally.
All right. Please give a big applause to Frank. Thank you. So we have about 20 minutes break, and we will be back with sessions at 7:45. Enjoy.
Hello? All right, it's working. All right, hey everyone, super excited to kick off the second round of lightning talks here. I'm Shing, I'm from the Databricks ML team, and I'll be your MC and host for tonight. But we'll just kick it off. So to start off, we have Christopher Nguyen here, and he is gonna tell us about not LLMs.
All right, thank you, Shing. I'm sure you're all here because of the Elon Musk hook, right? No? Okay, good. Because I want to talk about something else. I want to talk about, I'm also not talking about LLM, I'm talking about the opposite of it, right? SSM. So if you're interested about that, you know, essentially you can scan the QR code because we're open sourcing that. But I'm going to motivate you through it. So I do have to talk about Elon. He's right about a few things, right? So he says that there's a major misallocation of capital in Silicon Valley, right? And the fact that there's epic success waiting for talent who would go into the manufacturing and heavy industries. And my own background, my previous company was acquired by Panasonic, so I ended up running global industrial AI for the company for 4 years. And that's how I discovered this space, if you will. Although my PhD was semiconductor many years ago, so I'm kind of returning to my physical roots after 30-year career in the digital space. If you look at the geopolitics around money, right, flowing back into the U.S., a lot of it is because manufacturing, advanced manufacturing, that kind of muscle has been hollowed out in the U.S. in the last 20, 30 years, right? Mark Andreessen famously said, software is eating the world. But also recently he said, let's build again, right? So there's a lot, if you pay attention, for example, how many people know that Panasonic, LG, and so on are investing tens of billions of dollars in Alabama and in Kansas for EV battery plants, right? And of course, as you know, TSMC is investing $100 billion in trying to replicate their factories in Phoenix. Now, how many people were at the panel that I was on just earlier? Okay, so you already know the answer to the next question, so try to. So this chart is a survey to say, essentially how techno-optimistic are the various countries, and then I was curious, I took that and I did a scatter plot against GDP per capita, and kind of as expected, right? Rich countries are more techno-optimist, and poor or emerging economies are less so. And this was it was a 2021 survey against 2022 GDP per capita, right? So, but the question then is, a lot of us are here because of data and AI. And so earlier I sort of asked this question, and I didn't have the chart, but now I do, that you can see. What do you think the trend is if you ask sort of the same thing, but you ask about AI technology in general? How many people think that rich countries are more optimistic? How many people think that emerging economies are more optimistic about AI? Okay, and the rest of you are sort of on the fence, right? So I did the same. This is coming from the Stanford HAI State of AI report, and it turns out, first of all, the correlation is very strong. R squared is 66%, right? But emerging economies, India, Peru, South Africa, Argentina, and so on, compared to Australia, United States. Right? So earlier we talked about trust and so on, but I thought about this a lot. Now we know that the correlation is real, but we don't know what the cause is. And I would like to propose one reason for it to you. And that is, right, from my experience trying to solve problem at a physical company like Panasonic, right? Panasonic, as you may know, make EV batteries for Tesla, avionics, right? If you fly, the IFE, the in-flight entertainment system, 75% of the world's, you look enough at the logo, it'll say Panasonic Avionics. We failed when the company was just acquired, and then we tried to do predictive maintenance, and everybody who's done predictive maintenance here knows that the limit of it is anomaly detection. But that's not quite predictive maintenance yet. It turns out that we figured out that if we incorporate domain expertise, which is the stuff that is outside the sensor data, then you can really solve problems. Then the question is, how do you encode domain expertise without going back to expert systems. And so actually about 3 years ago, right, so I stayed in touch with my friends at Google Brain and sort of knew where LLMs were going. So we should begin to apply language models, right, as that translation layer. So I like to say that LLMs are more of a revolution in communication than of intelligence. So LLMs can now translate that domain knowledge. If you think about that, then it kind of makes sense that countries that are still making things, the physical economies, I think the marginal gain from the application of these foundation models can be even larger than companies that are service-oriented like ours. So here's an example use case that we have built, as part of this new company that I have launched called Itomatic in 2021. How many people are familiar? How many people know semiconductor really well? Have you heard of atomic layer deposition machines? Right? Exactly. So the precision is 10 layers of atom across a 12-inch wafer, right? So you can imagine that's, I don't know, you do the calculations like Earth, and then you care about the flatness that's knee-deep. This is for a field service technician, engineer, to try to solve and diagnose a problem in such a system. In the past, this is such advanced technology that, and as you know, in the semiconductor industry, there's a lot of secrecy. Like TSMC engineers don't want to talk to applied materials engineers, even though they're vendor and customer, because there's a lot of competitive information. So with this system in between, and it's more than just an LLM, I call it a problem-solving system, they're able to do that. We help them encode domain expertise from both sides, and they interact with each other as virtual agents. And so, in the last 2 years, we've implemented a lot of things around industrial boilers, commercial refrigeration, gas refinery, factory pumps. These are the stuff that we depend on to live, right? It's a $25 trillion economy. And yet most of us here in Silicon Valley don't really think about it, much less really know about the physics and the domain expertise that is needed to really solve these problems. And that's why there's huge opportunities in this industry. So if you remember nothing else, there's a symposium that will take place at Stanford in October. Folks like myself, Hitachi, Westinghouse, Petronas, which is oil and gas, Panasonic, and so on. People who come and talk about these things, right? So I want to move quickly to sort of the architecture of the thing. How many people are familiar with Yann LeCun's gripes about LLMs, right? He's right about one thing. LLMs by themselves cannot solve problems, right? They can do inferencing, right? But you need something, you need a loop, right? And you can read a lot more about that. But we're already building those things, right? This is here, I know it's a simple architecture, but it's kind of dense. I want you to pay attention to the items in the black box. That's what we call SSM, okay? And the key to SSM is that they are small specialist models. So it turns out the key to solving problems is not bigger and bigger models, right? The language model layer is used only for communication. Think of it as the API. But what we do is we combine 5, 6, 7, even dozens of domain expert models, right? They are backed by documents, they're backed by knowledge, and they're connected to sensors. People talk about hallucination and so on. If you hear about sort of sensor-based or reality augmented retrieval, right? The truth is outside the LLM, right? So this is the general architecture called ICOM. And so SSMs we find are critical in problem solving, right? And this is actually the future, right? These are all names that you know about, and they're all seeing that the future is in what we call SSMs, right? Small specialist models. You can read up more on that, but here's my last slide, perfect timing. Today, we want to choose today to open source our SSM technology, right? Because we really want, I see millions of these SSMs. It's not like the dozens that our company's producing. And by the way, our customers love SSMs because they get to own them. And they don't have to depend on an OpenAI foundation layer for that. It turns out it's unnecessary. Okay, so there's a booth downstairs where you can learn a lot more about SSM and participate in this and contribute to the open source project. You can scan that, but okay, that's it.
All right, awesome. Thanks for the great talk. I'm excited to hear more about open SSMs in the future. All right, so next we have a talk from Shreya, who's the founder and creator of Guardrails AI. And she's going to tell us more about risk and safety in LLMs. All right. Give you a minute to plug in.
All right, hey everyone, thank you so much for coming, especially at 8 p.m. I hope I'm not keeping you all from your dinner. All right, so at this talk, I'm going to be talking about practical guardrails for AI applications, and in real-world AI applications, how to ensure safety, reliability, and robustness. I'm the founder of Guardrails AI. My name is Shreya Rajpal, and I'll talk about how Guardrails AI can help you on this mission. Awesome, so why do we need guardrails? I'm sure everybody here already knows this, but I'm just going to give a quick refresher in case anyone doesn't. LLMs are absolutely awesome, but they are brittle and hard to control. Common issues that we all see as we are building with them in practice is that the LLM works while prototyping, but is flaky, especially when running in production. Getting correct outputs from LLMs always is hard. And common incorrectness that we see in practice are hallucinations, falsehoods, lack of correct structure, etc. Furthermore, the only tool that is available to you as a developer is the prompt. So what this actually ends up meaning is that whenever correctness is a critical requirement of the application that you're building, LLMs are currently severely restricted. So why is controlling LLMs hard in the first place? So there's 3 different ways that, as a developer, you can control an LLM output. The first one is through a prompt. And this is not, this is not an ideal way to go about it because LLMs are stochastic. And in practice, what this means is that even with the same input, so with the same prompt, you will see different outputs, just running it again and again. Prompts don't offer guarantees. So what you'll see people doing in practice is like adding a lot of exclamations, adding like instructions in all caps, do not print, very bad things will happen if you generate this output. And the LLM will listen to you sometimes, but also does not many times. The second option is controlling LLMs by tweaking the model itself. So there's a few issues here. The first is that it's expensive and time consuming to either train or fine tune a model on custom data. And if you're not training or fine-tuning a model, then LLMs are often hidden behind APIs. And as a developer, you don't really have access to model upgrades, et cetera. Even without the model version changing, the LLM under the hood might update, and all of your prompts, et cetera, will end up breaking. Our philosophy at Guardrails AI is that combining LLMs with output verification is the way to go. And what this means is application-specific checks and verification programs that ensure that the LLM output is always correct. And that's a mouthful, and over the course of this talk, I'm going to go into what that really means. Cool, so this is the flow that most of you, if you're developers, are used to, which is that you have some application logic, and within that application logic, you have a piece of the pie, which is the LLM. And how that operates is that you end up getting a prompt as input, and you send that prompt over to the LLM. The LLM generates a raw output, and you send it back into your application logic. The Guardrails view of the world is a little bit different, wherein you obviously have the LLM flow, wherein prompt, LLM API, raw output. What Guardrails does differently is that the raw output is first passed through to this verification suite. So this verification suite, contains a bunch of independent programs that verify whether that output is correct. So there's a bunch of these examples here. I hope people at the back can see what those examples read, but essentially making sure that there's no PII or personally identifying information. making sure that there's no profanity in the generated output. If you are building a commercial application, making sure that there's no mention of competitors. If you're generating code, then making sure that the code is executable. If you're doing something like summarization, then the summaries are similar, etc. So these checks can be anything, and they're often, application or domain specific, depending on what you're building. So the raw output of the LLM passes through to this verification suite. Each test in the suite either passes or fails. If everything passes validation, you're hunky-dory, you go on onwards to the application logic. If validation fails, there's a way of handling the failure so that you can re-prompt the LLM, give it context about why it's incorrect, and then ask it to correct itself. And that is one of the wonderful properties of LLMs, which is that they can self-heal if you tell them why they're wrong. This is obviously if you have enough budget and if if you have enough tokens or enough latency to support this. So what Guardrails AI does, Guardrails AI is a fully open source library that offers a framework for creating custom validators. For example, we looked at 5 validators before, but you can create any number of custom validators. It is the orchestration system of prompting, verification, and re-prompting the LLM and managing that whole loop. It is a library of many commonly used validators across a bunch of use cases, etc. And it is a specification language for generating structured LLM outputs and communicating your correctness criteria to the LLM. So I'm going to showcase this with an example of getting correct SQL. So the problem here is that you are building an application that takes natural language questions over your data as input, and you want to generate SQL queries. And the database here, just so that you follow along with the example, is department management. So it's going to contain, department counts, number of employees, et cetera. So those types of records. So we're back to our diagram from before, but for people in the back, what's changed is instead of all of the suite of tests, we essentially have our application-specific tests, which are that the SQL is executable for your database. There are no private tables that are referred to in your generated query, and there are no risky predicates. So even if a user asks you to delete a table or something, you're not generating and running a drop table query. Awesome. So I'll walk through the workflow of what a Guardrails text-to-SQL application looks like. So which department has the most number of employees? The prompt that is constructed, essentially contains information about the schema for the database, as well as, question about the actual question that the user sends. Given this prompt, there's some raw output that is generated, and this is a very contrived example, but let's say there's a failure where there's a reference to a table that doesn't actually exist in the data. So you end up getting the table name departments, whereas departments is not a table in your DB. So when you run this generated LLM output through the verification suite, these 2 tests of no private tables, no risky predicates pass, but your SQL is not executable because that table doesn't exist. So how Guardrails works is a reask prompt is automatically generated for you with all of the relevant context about why that why that query is incorrect. So for example, this is obviously a simplification for the purposes of the demo, but an error, table departments not found. Please create new SQL query that corrects this error. More information about the DB schema, etc., is all automatically created. We send this reask prompt back to the LLM and then end up getting a new raw output here. And this is what the output looks like. Again, for the purpose of the example, departments is automatically corrected to department. And then this time around, the verification logic passes. And so we continue and send this output back to our application system. Awesome. So that was the Guardrails overall workflow. Here's a very, very high-level overview of examples of some of the validators that exist in the package or that you can create with the system yourself. So very, very fundamental things like JSON structure and type checking exist, making sure that your URLs that are generating are valid are relevant to the text that you're generating. If you're generating strings, then there's no profanity in the text. If you're translating text, then the translation is high quality. Summarization is faithful to the original text, so all of the salient points that you care about in the original text are captured in the summary. Let's say you're building a chatbot for a healthcare company, then there's no healthcare advice within the generative text, so you're not being prescriptive, which is against the law, as far as I understand. A customer service bot doesn't ask private questions, generated code is bug-free, etc. So in the demo, I basically talked about re-asking as a way to handle validation failures, but Guardrail supports a bunch of other configurable options. So if any guardrail specifically fails, you can obviously re-ask, and all of the re-asking orchestration and prompt construction is automatically handled for you, but you can also programmatically fix it if it is possible to programmatically fix queries. Filter offending values, filter specific texts that are, let's say, have profanity, etc. Refrain from answering. Maybe your response is so bad that you don't want to handle it. No-op, in this case, no action will be taken, but logs about why validation failed will automatically be stored for you, and you can do whatever you please with the logs. And then finally, raise an exception. So I have a quick demo. I am very close to being out of time, but maybe I'll just quickly showcase what this looks like in practice. So here is the text-to-SQL endpoint for Guardrails. This is basically configured with this configuration markup. Essentially, what you can do here is talk about which validators you care about connecting. And then what you can also do here is hook this up with a database that contains previous examples. So this will automatically, figure out the relevant examples for you and inject it into your prompt so that, so that your LLM is able to more correctly generate responses. It will do verification for you, and it'll do re-asking, etc. So I tried this earlier, and my internet is kind of slow here, so this may or may not run, but this is an example of calling it for the example of what is the name of the department with the highest number of employees. And I think my internet is kind of broken, so this won't run. So, but I'm going to give it a shot. But what I really want to demonstrate while that is running is what happens when we have an incorrect output. So with the, okay, so it ran, and this is the query we ended up getting. But in case there's an incorrect output, you can pass this incorrect output, with correction for validation, and this is what it kind of looks like. Whoops, I think I did not run this. This is what it looks like, but under the hood, this is what it's doing, where this is the raw LLM output that we end up getting. Select name from departments. After validation, we see that this is why it's incorrect, along with all of the context of why it is incorrect. A new prompt, this is automatically constructed under the hood without you having to do anything. So this new prompt is automatically constructed with all relevant information. We end up getting a new LLM response back. And then the new LLM response is validated, no validation failures are found. And so this output is returned to the user directly. So once again, what Guardrails offers: framework for creating validators, orchestration of prompting, verification, reprompting, library of many commonly used validators, and a specification language for communicating with the LLMs. Awesome. To follow along, you can, I hope you can see this, but you can check out the GitHub project on shreya.r/guardrails. The documentation is at getguardrails.ai, or you can follow me on Twitter at ShreyaR. Or guardrails_AI, where I talk about this constantly. Thank you so much.
Awesome. Thanks so much. Yeah, super important topic these days, so lots of interest from people. All right, so next we have Xingyang, who is coming from the Berkeley AI Research Lab, and he's going to tell us about training framework for LLMs. And I think Xingyang's group created the Koala model, I believe, right? It was the, yep, awesome. Okay, so yeah, take it away.
Hi, everyone. My name is Xingyang. I'm a PhD student in UC Berkeley. And as Shreya mentioned last time in last talk, that training LLMs is very difficult, and tweaking with the model is also not easy to do. And today I'm presenting EasyLM, a simple and scalable framework precisely to do that. And hopefully with this 15 minutes of talk, I will convince you that it's actually not so difficult to customize and train your own large language models. So if we look at existing frameworks for training large language models, I'll borrow this picture from this famous picture from Angry Kaparsi from his most famous MinGPT, now NanoGPT implementation. Most of the existing frameworks fall into two categories. The scalable frameworks are very complex. They're like a humongous battleship that has all these bells and whistles. And also the simple didactic frameworks that are very easy and minimal and very easy to use. So let's dive into each of these frameworks and see why that's the case. So if you look at mostly these educational frameworks that's very easy to use and easy to learn, we see that this is because essentially causal language models are very simple. They're standardized transformer architectures with only minor tweaks. And the training methods for these language models are also quite standardized. You just use supervised fine-tuning, you use Atom Optimizer. All of these things have basic standard implementations in today's neural network libraries and only require minimal coding on the user side. So why do we still have these complicated language model frameworks? The heavy lifting is mostly for the scalability. The previous minimal language model framework, if you just run it on a single GPU or on a few GPUs on a single machine, that might be sufficient. But if you want to scale up your training in the cloud on many different machines, on hundreds of GPUs or TPUs, it's very difficult. So these scalable language model frameworks are often built to handle that case. On the other hand, these scaling mechanisms are often deeply integrated into the model and training loop, make it very difficult to customize. For example, if you want to build your own language model, you want to take an existing complicated implementation, it's very difficult to do. And I was wondering, can we actually bridge the gap between this minimal language model framework and the scalable language model frameworks? And I believe with today's machine learning framework, we actually can. And this is my analogy here. It's like a futuristic battleship that's very powerful, but automatically controlled. That means it doesn't need much input from the user to be able to do the very scalable heavy lifting. So how does it work? The key ideas is we can actually keep the model and the training loop of the minimal language model framework to be minimal and simple. And we leverage modern machine learning compilers to automatically scale up the computation. So this is the framework we developed called EasyLM. And as you can see, it gains quite a lot of stars on GitHub, and you can also scan this QR code to see the framework itself. EasyLM has a lot of support for existing popular open source language models such as Llama and GPT-J. And it also integrates deeply with the Hugging Face transformer ecosystem. That means that language model trained with EasyLM can be easily exported to the Hugging Face format. And it supports flexible parallelism and has a lot of built-in bells and whistles for model serving and evaluation. So let's dive deeper into it. So first of all, when you write a language model in EasyLM training, you mostly just write a model for a single GPU. So look at the training code here. It's essentially just computing the logits and computing the loss as if you're doing the computation on a single GPU. This makes it possible to directly expose all the essential model details, such as the model definition and the loss function, directly to the user without dealing with hundreds of lines of complicated code. This makes the language model really customizable. But how do we scale it up? We scale it up automatically with modern machine learning compiler. So since EasyLM is building JAX, we're able to leverage JAX parallel JIT compiler to automatically transform the simple train loop we defined before into scalable multi-host, multi-accelerator programs. So how to do that? The first step is for user to simply provide what's called a sharding rule. And these sharding rules are mostly standard for modern transformers. You can just copy it from somewhere else, and you don't have to really write it yourself. And once you have the sharding rule, you can use this compiler to directly transform the single GPU program you defined before into a scalable program. So after you transform it into a scalable program, you then provide simple specifications of parallelism by basically providing 3 numbers of the shapes of your accelerator configuration. And EasyLM supports a flexible 3D mesh of parallelism, including a mixture of tensor parallelism, fully sharded data parallelism, also known as 0-stage 3, and also the normal replicated data parallelism. And as the example here, I'm showing you simply just provide 3 numbers, then you can scale up your training program to 256 accelerators, covering a group of 4 data parallelism groups, 16 ways of fully sharded data parallelism, and 4 ways of tensor parallelism. Now, with all these simple program to set up, how does it perform? It actually performed decently compared to both existing open source implementations and also commercial solutions. Here's a comparison of our throughput in training our 7 billion OpenLlama model. We can see that on A100, we actually achieved comparable throughput to Mosaic's MPT7B model, which is a very popular commercial solution these days acquired by Databricks. And also, we're doing better on TPU than Google's T5X open source solution, which is a much more complicated implementation, which is better for larger models, but not so good for these smaller models. And running EasyLM is also very simple. All the training configurations is basically exposed via command line arguments. This means that you only need to write 1 single script for all configurations. You don't have to deal with all these complicated levels of YAML configuration file, just 1 single script. You can launch your experiment and run. Now, in today's talk, I'll also give you 2 use cases of EasyLM, of models trained with EasyLM. Oh, one more thing to add here, we also have built-in support with serving the model and also evaluating the model and having a chat UI. So you can directly play with the model you train. Today, we'll also give you 2 examples of model training with EasyLM, hopefully to convince you that it's actually not so difficult to do. So the first model is what we call the Koala, a dialogue model we trained here in UC Berkeley. It's essentially very similar to all these various styles of fine-tuned llama, including things like Alpaca and Vicuna. And basically, we took the shared GPT data online and fine-tuned our llama to become an instruction-following model. The fine-tuning, as you can see here, is very cheap. It's fine-tuning on a single AGPU machine for only 6 hours. This means that you can actually do the complete fine-tuning run with less than $100 on cloud with Spot instances. And I'm pretty sure any company can afford this cost. So hopefully this will convince you that it's not so costly and so difficult to do. Now, how does this fine-tuned model perform? It actually, on the recently released results of LLM Chat Arena, which is comparing lots of different chatbots in a user study, we showed that Koala actually performs very comparably to the top-of-the-line fine-tuned llama model, which is Vicuna. And in the further study we study ourselves, we actually found out that some of our data we use during our fine-tuning time actually hurts the performance of the model. This really showcases that curating high-quality data set is very important, which is also another reason why you should fine-tune your own language model instead of using an existing language model via API. Now, this is a fine-tuning. This is for a smaller scale study. How does EasyLM help us train large language models scale up on hundreds of accelerators? We also did a project for pre-training language model, which is OpenLlama. One of the main bottleneck we see with Llama-style models is that Llama is released not under a commercial license, it's under an academic research-only license. And many people who want to use Llama for their startups, for their business, cannot do so because of a license. And on the other hand, people have built a lot of great ecosystems around the Llama models, such as Llama CPP, such as these very fast on-device inference engines. So seeing these opportunities, we decided to take some of the computation resources we have, also some resources sponsored from Stability AI, to basically replicate the pre-training of Llama to create a completely permissive licensed Llama reproduction that can serve as direct replacement as the original Llama weights. So we released a series of pre-training, including the smallest model like a 3 billion model, a 7 billion, and a 13 billion model on this RepPajama dataset, which is a reproduction of a Llama dataset released with, from a company called Together. And the model pre-trained on these RepPajama dataset can directly serve as drop-in replacement. It uses the exact same Llama architecture. Any code you written for Llama can directly use this. On our zero-shot benchmark evaluations, we actually also see that our reproduction of Llama reaches comparable performance to the original Llama models, which is shown in the table here. So this hopefully can convince you that actually training your own language model is not so difficult, and you can leverage a lot of open source frameworks and the open source model as your base model to start fine-tuning and customize it for your own business. If you're interested in this work, please scan this QR code to see our framework on GitHub, and also maybe talk to me after the talk.
All right. Awesome. Thanks for that. Super interesting. All right. So next we have Anshul from Codium. Yeah, there it is. Great. And he is going to tell us about a coding assistant using LLMs.
Can people hear me? All right, I can hear myself, so that's good. All right, cool. Hi everyone, I'm Anshul. I'm from the team at Codium, C-O-D-I-U-M. And today I'm going to try to switch things up a little. We've been talking a lot about a lot of the technical details and lots of fun training graphs and whatnot. I'm going to kind of shift it a little bit more to the product view and give a little bit of insight on things that we learned while building an LLM application of our own. So, a little bit of context here. What am I talking about? About 9 months ago, my engineering friends and myself, we're all engineers, we all were trying GitHub Copilot, and we're like, wow, this is pretty awesome, right? This is going to be the future of software engineering, AI helping to accelerate everyone. But looking at our own kind of workflows, we realized that just the autocomplete functionality was kind of a small piece of what we need to do as developers. So we kind of thought, well, this is probably a pretty good place for us to try to build our own GitHub Copilot++, right? And that's kind of what the start of Codium was. And just to give some a bit of idea of where we're at right now, we're kind of building this entire AI toolkit, right? The idea that autocomplete is just one part. We've also done IDE integrated chat, natural language search, a bunch of things that really address different parts of the software development lifecycle. Today, we have over 100,000 developers using our platform, and I think probably more interestingly, we've actually sold the software to enterprises ranging from startups to Fortune 500 companies. So pretty much the whole point of what I want to talk to you about today is what did we wish we actually knew to kind of get to this point, right? And everything I'm going to talk about is kind of our distilled look back in the 9 months of things that, how things kind of made sense. We definitely didn't actively think about that in the time. So hopefully this will add a little bit of structure to the idea of how do you actually go from a cool idea of using AI to an actual application that you can scale, have users, and sell, right? So I think this is probably the number one thing, which is identifying a sustainable product. And what I mean by this is kind of looking at the very end state, right? What does it look like 3 years, 4 years down the line if everything goes well? And we kind of distilled what a sustainable product really looks like into generally 3 bullet points. The first thing is, no matter what kind of application you're targeting, like for us, for software development, you should be able eventually to address the complete set of subtasks. Otherwise, it's just an incomplete product, right? Otherwise, people have to pull in products from a bunch of different places to actually satisfy everything they need. The second thing we realize is that if you're going to be, is there a lot of echo? If you're going to be kind of like the leader in any kind of space, you need to actually understand the user and how can you make your product the best for that user for that task. Right? A generic system will always be able to beat will always be beaten by a system that is more specific to a certain person. And the third thing, and something that we probably should have learned a long time ago, is that the AI should be a clear win. If you're going to kind of sell to a corporation or to an individual, if you have them questioning, like, oh, am I giving something up by using this? You're going to be hitting a lot more kind of roadblocks along the way. So what does this mean kind of practically, for example, the code situation like we are? We realize that we actually need to accelerate every aspect of the software development lifecycle, right? Just stopping at autocomplete wouldn't be the answer. We needed to realize that we have to leverage individuals' users' data, like, for example, a company's existing IP, in order to create the best product for a company. Otherwise, we'll get potentially beaten out by someone who does build a specific product for that company. And at the same time, if we're going to sell to a company, we can't have any caveats on security, legal, cost, pretty much anything that makes a company question whether or not this investment is worth it. So some thoughts here. Probably heard this one before. An API wrapper around something like OpenAI is not a sustainable solution. And there's a lot of reasons for this, right? That very first bullet point of you should be able to go for every single subtask. This actually scales really quickly. And if you just look at the costs, right, for any of these API calls, something like an OpenAI, I think GPT 3.5, is about 0.2 cents for every 1,000 tokens. Let's put this in a little bit of context. A single call for something like GitHub Copilot for code has a context length of about 2048 tokens. Right? So about 2,000 tokens. On the daily, you're creating an autocomplete suggestion for every keystroke. You're doing that probably a couple thousand times a day for every developer. So what we're talking about is actually a few dollars per day just of OpenAI calls. And that's not a cost that you will be able to fully pass on to a developer. Right? No one's going to pay maybe thousands of dollars a year out of their own pocket, right? Even if the value is there. That's a pretty large thing to swallow. And so you start adding like chat calls and search calls and your own vector database, and you're asking the user to actually front all of these things. Really wrapping around this becomes an unsustainable thing from a purely financial point of view. Second thought is understanding kind of what the actual differentiator that you could use that actually could be a real moat. For example, we didn't go into Codium thinking that we're going to build, the best foundation model. We're not going to drop, tens of millions of dollars to train the next GPT-4. But what we did realize is that any kind of generic model wouldn't have access to, for example, a company's internal code. So now if we could create a solution that could leverage a company's internal code, we could actually make use of a differentiator that any generic product doesn't have access to. And so understanding where actually the differentiators is, I know there's been a lot of talk about what's the moat with LLMs. I would probably say this is answer number one, right? Leveraging data that no generic model will ever see the light of day. So anyone building a wrapper product also won't have access to this, right? And the third thought kind of comes to that very last point of there shouldn't be any caveats. And so if you're able to prioritize the control over your own models, you can do a lot of really interesting things, right? And we'll go kind of more into details in terms of code where that comes into play. So the second kind of general overarching thing that we wish we kind of knew is figuring out all the different ways that you can actually differentiate your LLM application. The first one that I've already alluded to is data, right? Not only is data, the user data not going to see the light of day, this can actually become a real way to actually improve the quality of your product. As I said, a solution like a GitHub Copilot might take about 2,048 tokens of context. Just to put that into kind of like, actual things that we can rationalize, that's about 150 to 200 lines of code. That's really not a lot, right? If you think about your own code base that you're coding in and you're typing, well, all of your internal libraries, your syntax, your semantics, how can that all really fit into like 150, 200 lines of code, even if you knew the exact right best lines of code to put in there? So if you have access to the user data, can we actually use that in actually training the model, right? Fine-tuning the model in order to improve the performance? So this is one way that you can actually differentiate your model for a customer or a user from any kind of other product or generic model out there. The second one is via UX, right? Even if you are just an OpenAI wrapper, this is probably what you're going to focus on most of the time, right? How can we create the user interface in a way that is not just more available to the user or more practical and streamlined, but also makes the AI more powerful for the user, right? How can they actually discover how to best leverage an LLM because to be honest, all of us are still trying to figure out what all these LLMs are capable of doing. And so here's one of the examples of our chat feature where you can see it's like a ChatGPT window, but how tightly integrated it is into the IDEs with little code length suggestions, ways to actually copy in the code back into a diff, back into the IDE, a little bit of confetti for fun. All of these kind of things just to make that user experience a lot better. So this is another place to really focus on. And the third part that we realize is actually there are some things from the model level. And if you do control your model, you can actually do model level changes to improve the quality of the model. For code, there's a very interesting situation, like unlike a ChatGPT where there's context in, you produce context out. For code, both the context before and after the cursor really matters, right? So it's this task called fill in the middle, right? Filling in kind of the tokens in between context. And this is actually a training pre-task, like it's a task during the training process. And if you can control your model, you're actually able to do things like this. So code has some of these interesting things, and I'm sure other applications have unique aspects of how the product could be best used, which can actually trickle all the way down to the model level. So the more you can actually vertically integrate your whole application, the more you can do kind of fun things that would just improve the quality of the product. And the third overarching thing that we wish we kind of knew is addressing all of the needs that a user might have. And these needs are often not actually the model. So we spend a lot of time in these kind of sessions and these kind of venues talking about all the new coolest tech to create all the best models. But in reality, if you actually want to sell a product, what we realized that we learned is that people care about other things, right? People care about security, right? You hear this all the time. I don't want my company's IP leaking out into the wild. I mean, there's been tons of really fun headlines over the last few months. I think my favorite one was last week, I think Google telling their own employees not to use Bard. But there's real concerns around security and privacy. And so one thing that we learned we had to do is that for any enterprise, we actually have to fully self-host our solution, right? Make sure that companies can be very confident that none of their IP is leaving. People have real legal concerns, right? You take something like a Copilot and it's trained on GPL code, and so it regurgitates GPL code, and people get scared because there's legal ramifications. This is where owning your entire model end-to-end really helps. We're able to kind of remove all of non-permissively licensed code from our training data. Again, something you can't really do if you don't fully own kind of the model, not just the model architecture, but the whole training process end-to-end. So that's kind of pretty much the highlights of what I wanted to talk about, right? And just to recap, I think the main things that, if we had gone back and we did everything linearly, and this is all nicely formatted, but we absolutely didn't end up here like that. This is kind of what I wish someone had told us, right? Really start with kind of that end goal. What does it actually look like to have a successful, sustainable end product? You're not going to get there immediately. We're still on our way. But the people who kind of like understand that, hey, user data is the moat and owning their model, you already see them having success. I think a lot of us here have heard about Harvey, right? Their whole thing is being able to train on the legal data of all of the people they partner with, right? It's these people that have figured out these aspects of the moat and really controlling that whole end-to-end to understand kind of how you eventually make money in a sustainable way. Then figuring out how to differentiate. Wish we knew that UX was a real lever that we could pull, and we weren't just trying to rely on the UX that was well accepted from like a ChatGPT chat box or an autocomplete Copilot. And finally, understand all of the needs of your eventual customer, right? They're going to have concerns far past just the actual model, and enumerating all of that will help you actually work on building the roadmap in reverse, right? We realized, okay, we need to have a self-hosted enterprise solution. What does that actually mean? Well, if it's self-hosted, we don't get any feedback from the user. So if we want to iterate on our product, that means we actually need to create an individual plan, right? So that we can actually have individual users use our product, iterate on it, give us feedback, right? If it's going to be self-hosted, that means they're going to have to pay for the actual infrastructure, which means we need to invest a lot of time in optimizing that to work on cheap GPUs. Okay, and now if we combine those two, we need an individual plan, and we have cheap GPUs. Why don't we just give this entire individual product for free, right? And that's actually what we've ended up doing. So just to end, thanks for listening. And my final blurb, try out Codium. It's free.
All right, thanks. Yeah, that was great. Great lessons learned. All right. And then last but not least, we have Akrati from Databricks to tell us about context retrieval using using a feature store for LLMs.
Sorry, you all had to see that. My name is Akriti, and thank you, Shing, for introducing me earlier. I'm an engineer on Databricks' I'm an engineer on Databricks' machine learning platform team, and I'm here today to talk about feature and function serving in the Lakehouse. Cool. So, all right, so let's forget for a second that I work at Databricks, and let's think that I am building a traditional hotel booking website. So what, most likely, like my website is built on top of a web application that takes in users' city of interest, some booking dates, performs a personalized search on top of it, and does some machine learning ranking on it. It's pretty good, but it cannot answer like all of users' questions. So that's why in today's presentation, like we'll look at how we can build a personalized chatbot for my hotel booking website by using a large language model. And we'll also see how we can leverage the enterprise data that can make the LLM chatbot very powerful with the personalized context. So we learned a lot about LLMs today, and this is the last talk, so I'll not take too long, I promise. And, but LLMs are extremely good, right? Like, they are very good at understanding human language, their intent, and most common use cases that we have seen are answering questions and generating texts. So we also know that there's a lot of research that's done on vector databases that can provide like approximate information for the LLMs. However, we can make LLMs even more powerful, like, and even more performant using, by retrieving personalized and giving it personalized context information. So that's what I want to talk about today. But before we do that, let's take an example of what an interaction with a generic chatbot would look like. So my chatbot uses here, like, I used an out-of-box OpenAI model, and then I asked it to create a 7-day vacation plan for a user on my website. User wanted to travel to Amalfi Coast in September. I didn't do any additional fine-tuning or didn't provide any additional context. Chatbot was good. It was able to understand first that user is planning a vacation, And then second, that user needs to book some flights and accommodation. Good. But like, it doesn't know a lot of things, right? It doesn't know that anything about my user, literally. And what kind of vacation do they generally book? What is their typical budget? What accommodation they like. Like, do they like beach-facing rooms? So that is all information that is missing. And this is exactly what the enterprise data in my Lakehouse has. So we'll look at how my Lakehouse can provide all that information in a personalized context. So, all right. So my Databricks Lakehouse already has this enterprise data from my website. Databricks has recently launched this functionality to serve any business data and functions at a very low latency in a real-time endpoint. It's called feature and function serving. And all I need to do is store my business data in the Lakehouse and serve it using one of these real-time endpoints. By the way, if you are using model serving, you already have all of this functionality integrated for you. So let's see, like I have all my data, I have my feature function serving endpoint. Let's see how I can use it in a real-time LLM application. So remember, we were booking a hotel booking chatbot. So this hotel booking chatbot has my user data, which is like users' budget, some hotel data, such as hotels availability and discounts. So we will serve all of this data using a feature and function serving endpoint, and then use it in the LLMs to provide personalized context. Let's see how this workflow would look like for my website. So when a user asks AI bot to create a travel plan for them, there are many things that my Lakehouse already knows. First, what do I know about the user? I know that the user has a budget and some preferences, like they might like a quiet place or they might like a downtowny place. They might like a beach-facing room, for example. Then from this information, I can do a top-case search based on their preferences. And then I can use a feature serving endpoint to get real-time availability and prices for their preferred hotels. Finally, I can do on-demand calculation of the hotel price for vacation. So using any custom code that user can create within the Lakehouse. So I think we talked about like all the awesome functionality. So let's see some of it in action. To remind you, earlier we saw an example of a generic chatbot that could understand the user intent, but didn't know anything about the user. And it was asking, like, hey, can you tell me about who the user is, etc. So now we will use a feature and function serving endpoint to provide some of that context information, and we'll create some tools in LangChain, which are basically helper functions, like if you haven't used them before, that takes some input and produces some output that is used by an AI chatbot. So let's see the example here. Okay, let me, okay, all right, cool. All right. So let's define this tool that is using a feature and function serving. My function serving is called, it's called user budget preference, and it is calling one of Databricks' endpoint. I'm providing it some token, some authentication, etc. And then I'm finally making a REST endpoint request. Similarly, I'm also defining a tool to retrieve hotels from the vector search. And then finally, I'm defining a tool to fetch prices and do some on-demand calculations. So let's set up an agent here. Let's see what's here. So as I earlier promised you, like we are using all these tools, which we just defined a few seconds ago. The user budget preference tool, the hotel retrieval tool, and the total price tool. And then finally, we are initializing the agent with the tools that we just defined, and using the same generic chatbot that wasn't able to give us a very useful answer earlier. So from this AI chatbot, we are also providing a prompt message that basically tells the chatbot as to provide some hints to the chatbot as to where it should go and fetch the information from the tools that we had defined earlier. So I'm telling it to basically fetch some budget preferences, etc. The agent can make decisions. So agent can basically make decision of when to use which tool when it is asked the question. And then it will provide all the input that the tool needs, and then it will use the tool's output to take next decision as to what to do. So, all right, enough talking. Let's call the AI bot and ask it the same question that we asked the generic chatbot earlier, which was to plan a 7-day vacation to Amalfi Coast around September for my user ID. Before I get into the details here, I want to show this is the output that it produced. It told me that there are some 4 great hotels that fit my budget from September 1st to September 8th. It told me that I should probably go book Hotel Miralfi, etc. And then it asked me for any further questions. So let's dive into how it really did that. Oops. All right. Let me go back. All right. We use 2-factor authentication. We are secure. All right. Cool. Yeah, this is what I wanted to show you. This is basically my chatbot in detail. It's basically first, so the agent is making decision to call the budget server tool first. It called the budget server. It got the observation here, which is my daily budget for this particular user is $700. Then it did a vector search and found out some 4 hotel IDs that were really ideal for my user's preferences. And then it basically called the hotel total price feature and function serving endpoint and got the hotel, all the hotel information that it finally displayed to us. So this is pretty powerful, right? Okay. So finally, I think, as I promised, I'll not take too much. As we saw, Databricks Lakehouse plus LLMs is really, really powerful. Using feature and function serving, I was able to seamlessly deliver the personalized context from my enterprise data to the LLM that I was using, which was a completely generic, non-fine-tuned LLM here. And I was able to run on-demand custom code that I had defined in the Lakehouse at low latency in a real-time endpoint. So that could have trade secrets, for example, for my website. And then finally, we used enterprise-level security behind these endpoints because all of this is governed in the Unity catalog. So I would only share the information to the caller that the user should have information for. Thank you. Thank you all for your time. I don't know, Xing, if we have any time for questions.
I think we'll probably wrap we might have 5 extra minutes. So if people have questions for any of the presenters, maybe we could have the presenters come up and we could take 5 minutes of questions if people want to hang out for 5 more.
All right. And if you have questions later, we have our email up here, feature-serving@databricks.com. So please reach out to us if you have any questions. Thank you.
All right, thanks everyone for coming. Yeah, that's it for the lightning talks. All right.